So hopefully some of you have had a look at the white paper already, which gives you a summary of these. But we need to keep track of what's happening technology-wise. We need to keep track of what you want to do.
Excuse me.
So,
You're going for the camera.
can do, then you can't see the screen.
Yes. Okay.
Okay.
Okay. Okay.
Didn't know I was on camera as well.
Smile.
This is extra. So we have the position of being familiar with what customers want to do, familiar with what technology does. We lead with similar technology, but we all use laptops and computers. I've been in the industry for 20 plus years, and we're always catching up with IT, as we were this morning. So IT is always going ahead. And then you have, as Vincent mentioned, the change of demand, the change of adversaries in defence, etc. And so it's hard to keep up with all of this. So what we try to do, again as Darryl is going to present next as well, is we're producing commercial off-the-shelf software, which either comes from an API level, so that we can develop with you or you can develop yourselves, or we use full products that are installed, ready to use. So it depends which level of use you wish to have, whether it's plug and play, so install and use a product, or whether it's at the API level and you build and integrate. So we're developing these COT solutions. So as mentioned earlier on, one of these is around tactical cloud, making use of, we'll say a cloud, but it could be your laptop, it can be, a cloud is a computer somewhere, so whatever the computer may be, and we're wanting to bring together the, as again Vincent mentioned, the ability to catalogue the data and make it available without thinking about it. Now, it doesn't sound hard, and technology-wise it isn't hard, but it's just putting those pieces together to make sure that people have access to the data when they need it. And not all the data. We can show you demos and videos that have hundreds of thousands of tracks, gigabytes, petabytes of data. So what? It's no use to you. You want to know the difference or the bit of data that's relevant to your particular operations or your question that you have for today that you need to answer. So by combining these different technologies through, we're able to put together very easy to use, very easy to deploy ways of cataloguing data and then making that data available through standard web services, so that the end users, as the sort of clients that you saw earlier on from EGOS, so the end users have a simple client, simple web interface, browser interface, so they can interact with that. Now, we focused in this solution for a lightweight installation, because if you say to a deployed unit, you have to install some software, you have to configure this and do the administration, they don't want to know. They might have a geo expert, they may not have a geo expert, they probably haven't got an IT expert. So deployment is very easy. It's one installer for the server and for the client. And then easy to use, easy to run. It's a very simple concept. The solution watches folders so that it will update and make the data available on demand. And we'll have a demo and a video of that later on. Similarly for on cloud, within our combined history, we have 40, 50, 60 years of technology from Hexagon and, as you heard mentioned, the companies that Hexagon has acquired. So that's all very good, and a lot of that is desktop based, which is good software, but it's on a machine. Nowadays you want it deployed to the users without managing their machines. You just want to deploy the data, deploy the capability. So MapX is one way that we do this. Again, it's a cloud or server-based piece of technology, and it's very much focused on delivering an image intelligence workflow via a browser. So whilst you have all of the rich capability, which again we can demonstrate on desktop for change detection or visualization or terrain analysis, having that from a browser-based application is something different and something new. I know it's implemented around Italy. But then each of these clients, from their browsers, has the ability to analyse data, interrogate data, and see the results. The results can also be back catalogued, so the next person with the same question sees the results. If they have a different question, a different analysis, they can obviously run that analysis themselves on new data or updated data. So we're delivering, or hopefully delivering, an easy-to-use interface. Again, this is browser-based. The screenshots will show that, but it's browser-based. And so you have analysis tools, you have enhancement tools there that you would expect to find in a heavyweight desktop client, but we're giving it through a browser. And then doing any heavy lifting on a server through web services to actually process the data on demand. One of the other good things that, again, we've done for many years in the desktop world is handle data in different ways. So whether it's image space, whether it's map space, whether it's 3D, from a user point of view, we want that to be one experience so that they can flick between those without concerning it, without re-projecting the data, without having to geolocate it or anything, or change hardware. Again, that's all doable in the browser nowadays. From one data set, one source, view it how the user wants it.
So another important trend, or rather sensor integration, has been in defense space for quite some time. And there are plenty of existing sensors, but every day new sensors are coming in the theater. So we used to know about Internet of Things, but nowadays there is a whole wide Internet of military things that needs to be integrated, planned, and visualize the data in a common operational picture. So the modern military and defense requirements, they rely on proven and scalable technologies in order to integrate all the sensors that are available nowadays. The sensors are deployed in harshest environment, in high temperature or in very cold temperature, on submarine ships, planes, UAVs, and all these sensors, they collect the data, and the sensors data are used to combine, to visualize, analyze, and then help military in decision making or act on that information. So traditionally the sensor fusion systems are more tightly coupled. So with the sensors you get a system, and only that particular system does the processing, and then you do a lot of efforts to send that sensor data to your, let's say, common command and control center or geospatial command and control center. So the need here is a software development kit or application programming interface that allows the sensor to operate and talk to each other, send data. Nowadays, even if irrespective of a maritime defense or aviation application, nowadays joint command control centers are coming in where agencies, they also need to share data with other applications or other command and control centers. So with the help of Luciad technology, it's very easy to integrate the sensor in their native format, no need of pre-processing, transformation, but directly connecting the output of the sensor to your command and control software, which is based on the Luciad portfolio. And then we can integrate sensor data coming from installed on various platforms. It can be a moving platform, it can be a soldier who is wearing some wearable sensors, or sensors in the battlefield surveillance or border management and security. All these sensors, they might detect different level of different aspects of data, heat, infrared, sound, light, tremors, but they're also, the sensors are also deployed somewhere. So location is the key. And also sensors generate some alerts. So having a sensor validate another sensor alert can help us to reduce false alarms. So sensor integration is a key of all the command and control and military application, because we rely on that sensor data. And to reduce the integration time in adding some new sensor that came, not redoing it from scratch, but just to add a module or integrate a new sensor on your existing application, the base or the code of your software should allow doing it very quickly and without disturbing the existing application or the operations of the existing application. So the interlinked command and control and geospatial software that provides the real-time view, coordination and interaction, and which is going to be the next future command and control center, should provide a high-speed, single information environment and enable quick, effective decision making. So here you see on the right-hand side we have our Luciad portfolio, which is used globally by major defense system integrators and even end users to build their defense applications, geospatial applications. And on the left-hand side, you see an Exalt framework from Hexagon, which helps to combine data coming from any different platforms, different applications. They might be in different programming language, they might be deployed on different operating systems, but Exalt provides you one single platform where all these data, whether it's coming from real-time sensors, from different applications, from your existing application services, can be brought into at one place and then served to all your applications in a standard format. Here, it's an example of an application Hexagon delivered to the Canada Ministry of Defense. They wanted an application where they wanted to analyze the plume dispersion model, so chemical, biological, and nuclear warfare, also sensor planning. But then, what if some bomb goes off or some kind of explosion happens? What will be the concentration of plumes in the air? What area will it spread? Where will be the maximum damage? To assess those and also to plan the sensors which will detect these kind of data to visualize for an end user. So this application, like I said, the map view you see Luciad. Luciad integrates with all the data sets, weather data coming from sensors. It also integrates with the plume modeling algorithm and many other type of sensor data, and gives you this application where you can not only visualize the plume in a 3D view, in a map view, but also analyze it in multiple dashboards or with the terrain elevation profile, and plan your sensor placement and also be ready for this kind of scenario. Another example here, you see that with General Atomics and US Air Force, this application is based on Luciad portfolio, Luciad Lightspeed, and it is used to control 2 MQ-9 Reaper drones simultaneously using a Xbox controller. So first, the pilot takes the control of the drones and it flies in the air, and then the operators on the system who want to gather intelligence, gather the data, they can take the control of the plane with the help of a Xbox controller or in controller, pass the inputs of speed, course to that particular aircraft via their flight propulsion system, and then position the aircraft anywhere they want.
So Vincent earlier on mentioned about AI and machine learning, which we both embed in our software and also give you some tools to utilise yourself. As mentioned, we can let you train data sets. So again, as mentioned, it's been around since the 1950s. We've been classifying imagery and classifying data for a long time, which is all versions of machine learning. And then nowadays, being able to go from just classifying a scene to picking out different objects, to working in semantics, and then working into instant semantics, so breaking down the image or the data set into whatever level of granularity you wish to have. And this has come about mainly that the maths have been around for a long time, but it's now having the processing power and the processing power to do that quickly, or relatively quickly, within a time frame that's useful. And again, having the ability to set what level of information do you want to know. Do you want to know that it's a town, or do you want to know what type of pantile is on the roof? It just depends what your information is that you're needing. And again, as mentioned, at the bottom of that slide, you don't run a marathon without training, so we offer the tools for training these data sets and putting those together. As well as I was just talking in the break, we have a technology centre who work above our divisions, and they're looking at all the different data sets that Hexagon can collect and work with, and then the different technologies for how we work with point clouds or dials on valves, etc. Or in this case, obviously radar data, and we have the radar expert here today. They're also, how do you pick out ships easily? We can detect that things have moved, but can you pick out the shape, the classification, etc. of those ships? And then similarly for picking out rail and road easily and from a few clicks from a radar data set in this case. So again, not having your analysts digitise roads, so whether you're doing quick classification or quick mapping or MGCP, whatever it may be, you can use these tools to give you the starting place in essence. I think we'd all agree that AI, some of the time, most of the time, gives you an assisted way of getting to data. It doesn't necessarily give you the ultimate way, but we're giving you the tools to take that step forward. and to obviously get the information out as quickly as you can, as we've mentioned a few times earlier.
Also, digital twins have been in the talk for when geospatial application comes more not into defense but in civil domain. But nowadays also defense industry is focusing on having a digital twin or a digital mimic of their any battle space where they can visualize all the layers of their application, 3D data sets, real-time sensor data, dynamic information, flying planes, or moving tanks in a digital reality view. And it helps the soldiers, the decision makers to more carefully analyze the data, mark some movements, do some training and exercises or for briefing. So we'll show you a couple of use cases. Here with one of the Hexagon technology sensor acquisition, a LiDAR sensor is mounted on top of the drone and can be before conceptualizing or an aircraft carrier is being scanned here, and it can for example, let's say if a new warship is going through a concept design or developers will soon be able to use its digital twin to experiment with spatial acceptance, and then for training or let's say for finding a void or during real-time operations, finding which part of the ship or the sensor, where is some damage, what needs to be repaired or monitored. The digital twin can help a lot. And not only, it also helps in real-time war and also in operational use case where soldiers can train, be aware of their aircraft carrier paths, weapons, where they are lying. And it's just not about having the information model of the aircraft carrier, but let's say drones are taking off or flights are taking off from a ship, submarine, or there are some other intrusion happens with everything on digitally available on your computer system, or let's say in a virtual reality view, you can easily integrate the new data sets and analyze the impact of what the impact will be if something new is added in this naval scenario. Same stands true for a battlefield. So for any kind of battle management training, simulation, exercises, once you have the digital twin of your battlefield, it can help not only from training and exercises, but also to real-time assistance in the operations. You can be telepresent from your command and control center to the border area or to the area of operation. And you can keep your soldiers informed via maybe a wearable sensor or a worn device that where they are, where the allies are, where adversaries are. But also getting information back from the sensor on soldiers such as location, view, ammunition, or also soldier health is possible with the digital twin in the battlefield. And another important trend which we found out being adopted in the defense industry is the use of immersive technologies. So we know about the word virtual reality, augmented reality. When both are combined and some other immersive technologies added, it becomes a mixed reality or an extended reality. So here on the right in this video you will see, okay, sorry for that, the devices are available and we can show it live instead of the video. So imagine a military-based training camp where soldiers will be able to use VR and AR technology based applications and train with virtual enemies and mimic the exact real battlefield environment. AR and VR can enhance the soldiers' cognitive abilities and put virtual trainings in line. AR is effective for warfare simulations, for battlefield visualization, military sand tables, exercises, and the use of AR in defense can be also done with the help of smart glasses that display all the available spatial information just in a holographic projection like some of you have already seen with the Microsoft HoloLens 2. And I would also like to invite you to see the application of immersive technologies when you wear a lens and how it can benefit your defense organizations. Here we have a video which is not playing, I think. So here it shows our Luciad portfolio integration with the open standards in extended reality. Most of you might be aware about the hardware acceleration, OpenGL and WebGL standards which were adopted. Nowadays, the industry is adopting extended reality standards on the open standard level. On the web, it is called WebXR, which is Web Extended Reality, and on the desktop, it is OpenXR, which is Open Extended Reality. And all the devices which you see, being HoloLens being the latest one, or the Oculus, on the back end, the code is written by using these libraries, WebXR and OpenXR integration. So, sorry, the video is not playing, but here in the Luciad RIA sample, you see one of our colleague is using a Oculus Quest, and this is a browser-based application, and completely a layer of game has been added on top of your geospatial application, or whether it's a command and control center where you can use your up, down keys, arrow keys, or the controller to do a first-person navigation. You can visualize your arms you're carrying, do some shooting exercises, hide behind buildings, do some, let's say, point-to-point line of sight, or 0 to 360 line of sight calculation, find the sniper position, and many more. So here, this video represents what you will see actually in the Microsoft HoloLens. So a city 3D model has been holographically projected. You see some labels, some tank and plane fly-throughs, and all the commands which you have in your geospatial application, which you do via keyboard or mouse, can be done with using hand gestures, like calculate the trajectory of a missile or launch a weapon. And this use case just displays all your geospatial application, your military application, in a holographic projection. And if, let's say, a few people are wearing the HoloLens, you have a team which is wearing the HoloLens, we can do some blue force, red force tracking, exercise, and visualize the battlefield in an extended reality view.
So hopefully that's given you a bit of a flavour as to how we can help automate data processing. As again Vincent mentioned, has been a theme all the way through. Some of what we do has quite simply been around for a while, but we're always adding new capabilities, new functionality to the automation, and that automation is across various different end uses and technologies. So whether it's, obviously our specialism is geospatial data, so working with data that has a pair of coordinates or XYZ, whatever it may be, and either placing that in a map or interrogating the data and then giving people a simple yes/no answer. That might be the result that they need. They may never see a map. That's up to your workflows rather than our technology. But having the automation across the piece and having it so that you can build, again we'll show you this in the second half, so that you can build the data workflows yourselves just using a no-code interface, so you just drag and drop the operators and the pieces that you want to process through the data. So there's a lot there to talk about. Next, Daryl's going to focus on some particular aspects of the radar, but for now, that's myself and Sarah up until our second half. Thank you.
Okay, grazie Richard, grazie Sara. Abbiamo visto una carrellata di tecnologie che per me